All right, everyone, super excited to have you back for another video here. So today we're going to take a look at outputs. Specifically, we're going to look at plotting. So basic plotting, basic 2D plots, how to make a basic plot, how to format that basic plot, and then how to use the hold on function. The other thing we're going to take a look at is formatting output for screen. So what that means is sending text to the screen in a formatted manner so it looks nice, all right? The good news about this is that's the first step into getting to file outputs and formatted file outputs. So this is pretty good stuff. Let's get learning. All right, so a couple of videos ago, we started with this idea of declaring inputs to our program. We then also used processes, and then we're going to take a look at outputs. So what we're going to start off with today is a little retrieval. All right, so what I'd like you to try and do is to create a couple of inputs. All right, so the input I'd like you to create today is a X vector that has 41 entries spaced equally from the value 1 to the value 10. All right, so that's the input I'd like you to create. The process I'd like you to perform is to create a Y vector that is the cosine of the X values. All right, so X vector, that's 41 elements, goes from 1 to 10. The Y vector is a cosine of that X vector. That's a process. So let's go ahead and do some retrieval. So pause the video and let's get retrieving. All right, so hopefully you've had a little bit of a chance to give that a try. What we're going to do next is actually try and do this in Matlab. So I'm going to load up my Matlab here, and I've already got a figure window here, so I'm going to talk about that in a second. But we're going to do the first couple of steps of this problem. So remember, we had some inputs, so I'm going to use a comment, so %sign input to the problem, right? So this is our format, input processes output. That's our simple program format. So the input is X equals, and if you remember from last time, it was a vector, equally spaced numbers from 1 to 10. So the way we might do that is linspace, 1 is the first number, to 10 is the second number, with 41 entries in that vector. So this linspace command will get us 41 entries starting from 1 and ending at 10. The second thing that I asked you to do from recall was the process. And I'm going to call this process number 1. And process number 1 here was Y equals the cosine of X. So remember we talked about the processes and commands, simple processes, simple commands. The cosine function here was a simple process that had an input X and an output Y. One of the things we haven't quite talked about yet is how processes can work with scalars, vectors, and matrices. So in this case, we have a vector as an input to this cosine process, and the output will be a Y vector of the cosine of X at all of the X points. At this point, we can run our program and we can see how it works. So let's hit run. And what we see is it runs plot example. I can look at the X vector, and that is going to have 41 entries that begin at 1 and go to 10. The other thing I can do is look at the Y vector, and I can see that this Y vector is a bunch of numbers that switch between positive and negative values, just like a cosine would with a cosine curve. So this is a little bit challenging to see in this Matlab format. So what we'd like to be able to do is actually to plot this. So what I'm going to do is I'm just going to take a guess that the command in Matlab is plot. And we're going to plot the X versus the Y values here. And I can run this now, once again, and what I can see is a plot of something that looks like a cosine has appeared in my figure window over here, which is pretty awesome. So what I can say is this is the output of my problem. So what I'd like to do today is I'd like to work on making this output a really, really nicely formatted output. All right, so what are some of the things that we can do? So right now this output is a line, So one of the things I might be interested in doing is changing how the line looks. So what I can do is I can just put directly after this a apostrophe, a dash, and an asterisk. And I'm just going to use run a lot here today. If I run this, what you can see is asterisks have appeared on this plot over here, wherever I have a data point. So what's pretty cool about that is I can create a data plot where I would simply have asterisks for that particular plot over here, right? So this is pretty neat stuff. So I can change the way the plot looks by changing the symbol inside of here. So I could also use squares with an S. So if I hit run now, you can see there's squares on the line. I can use triangles. So I can use the greater than sign, I believe. And let's take a look at that. And you can see triangles have appeared on my plot. I can use circles. I can also use a plus shape here. So there's all kinds of different options you have for making this plot work. So let's continue forward and say, what if we wanted to change the color of the plot, right? So one of the things we could do is we could come over here and we could say, let's just try and see what would happen if I put R here. And what you can see when we run that is that the line turns red, right? So the line color or the entire plot has changed color now. So what's good about this is I could plot a second process here. And I'm just going to change this here to processes like this. And I'm going to say Z here equals sine of X. So I might want to compare the X versus the Y of this. Or sorry, the y versus Z of this. My apologies. So let's do X comma Z. And then let's plot that with a line with circles with blue. Kind of like what we've been doing. So I'm going to hit run. And what you can see is I've created a line plot of the sine function, but the cosine function has disappeared. So that's a little bit concerning. So what do we need to do to make sure the cosine function stays there? So I'm going to type here, hold on. All right, and what that's going to do is it's going to hold the figure on between these two plot commands. So that was one of the key outcomes from today's lesson. You can see the hold on function. So we're going to see how that works here in a second. Right here, we see the hold on function is creating now two lines on this plot. So that's actually pretty neat. Now that we've turned hold on, we can actually turn hold off afterwards over here so that we don't continue to plot over that plot, right? Alternatively, we could also clear the figure up at the top at the beginning here. So I could also come up here to the very beginning of my program and I could type CLF, which clears my figure. So hopefully that makes some sense. I can also designate that this is going to be plotted on figure 1. So this is going to help me plot all of my information on figure 1. I could open a second plot by saying figure parentheses 2, and it would bring up a second plot window. I can make figure 10 appear next. I can make figure 1000 appear next. It really doesn't matter that you increment the figures by numbers exactly the same way. All right. So here we go. We've got our plot. It's starting to look a little nicer right there. And it seems to be working relatively well. So let's see what other things that we can do in this plot. So right now the lines might not be thick enough in some places. So why don't we try to make the line width a little bit thicker for the red line. So I'm going to say let's take the line width from a width of 1 currently to a width of 2. So I'm just going to put a comma here. I'm going to type in line width. And what you can see is the line becomes a thicker line. I can also append on this a marker. Let me actually go here, put apostrophe marker size variable. And that marker size, I'm going to make 15 for this. So I'm going to make really large markers on that line. And what you can see is I've managed to make what's probably not a great looking plot with much bigger markers on it. So I could actually go to a reasonable size marker, which would be marker size 6. And for the other plot, I could just copy this down here and I could put a marker size of 8. And let's take a look and see how that looks. So what we can see now is the marker size is a little smaller for the plus signs and a little bit larger for the circles. I might also try and change the colors of the actual markers themselves. So I can put in here the marker face color, which is going to be the color of the face of the marker. And I'm going to put in there a yellow for that particular marker face. And what we can see now is that the blue line has blue circles on the outer perimeter and yellow marker colors for the marker face. So my plot here now, I have a lot of control over the lines. There might be some other things I'd like to try and do to improve the plot. So one of the things I can do next is I can put a grid on like this. So I'm going to just turn on a grid. And when I turn on a grid, what you can see is that the grid lines for this plot have shown up so that it's easier to read. So that's a pretty nice feature. The other thing I might be able to do is I might be able to put an X label on the plot. So axis labels. The X label here is going to be my X value, like that. And my Y label, my Y-axis label, is going to be my Y value, like this. And I could also put a title, which is going to be plot of sine and cosine curves, like this. So when I run it now, you can see that I've gotten a plot of the sine and cosine curves as a title. I have the Y value label here. I have an X value label at the bottom. So let me actually just move that up a little bit and you'll be able to see it. X value right there. And then these lines themselves are formatted output lines. And I've got grid lines on this plot. So what you can see is I'm able to actually create a pretty nice plot at this point. It's still basic, but a pretty nice plot. So with this, we can create all kinds of different plots. So this is just one type of plot in Matlab. These are just some very starting point commands in Matlab. Down in the description below here, what I'm going to be doing is putting a link to a more advanced plotting example that you can try. The one additional thing I'd like to do before we stop this plotting example is right after this, I would like to put a legend. And I'm going to say the legend is going to be described by the first plot and then the second plot. So the first plot is a cosine plot. So I'm going to say cosine of x is the legend for the first plot. And the sine of x is the legend for the second plot, like that. So when I hit run now, you see that the legend here has appeared for this particular plot. And the legend has cosine of x and sine of x labeling those lines. So if there's one thing you remember about plotting, putting a legend on your plot is legendary. All right, so don't forget that little joke and put your legends on your plots. All right, so that's plotting in a nutshell. I just want to go over the different things we've done just so that we can revisit and refresh. So we started off by declaring inputs, which was our linspace command. We had two processes, y equals cos x, z equals sine x. And then we plotted the x versus y lines. And we had these quick shortcut versions of lines here where we changed the color. So I could put a black line and a magenta line in here. And if I take a look now, those have turned to black and magenta lines. I could choose any range of colors that Matlab has. I was able to change the line width, the marker size, and I was also able to change the marker face color. So some very basic changes to those lines. As I said, there's a video below which talks a little bit more about even more changes you can make, like font sizes, marker types, etc., like changing the grid sizes, really being able to control a plot very, very well. We also talked about the hold on command, which was between the two plot commands. It allowed us to essentially leave the existing plot in place and plot over it with a new plot, as opposed to erasing the plot that we had before and plotting a new plot as the new plot. Okay, we then talked about grid on. We talked about legends being legendary. We had an X label, a Y label, and a title for these plots. So that is my plotting in a nutshell. And we're going to switch gears to a new version of outputs. So let's just switch gears now. All right, so back to our learning objectives for this class. Next, we're going to talk about formatting outputs to screen. All right, so let's take a look at formatting outputs to screen. Before we do this, what I would like you to do is, again, another retrieval practice. So the retrieval practice for this is, remember a couple of videos ago we talked about the crop circle problem? What I'd like you to do is set up the problem so there's a radius of 800 and that you calculate the area and perimeter as processes to the problem for that circle. So radius 800 is your input, and then the crop circle area and perimeter are going to be processes of things you're going to calculate. So go and revisit that, retrieve it, write that code, and we'll be right back. All right, so welcome back from your recall practice or retrieval practice. We're going to get going with the sprintf command here. So sprintf represents screen print format. So we're going to print formatted stuff to the screen. There's a similar command, very, very similar, called fprintf, which is file print format. So once you learn about sprintf, you can easily transition to printing things to files and outputting files of text that are formatted in a really nice manner. So this is important stuff. Stick with it. It's a little bit complicated, but you'll learn it pretty quickly, and once you do, you'll find it invaluable. So the other thing I'm just going to quickly recommend is take a look at the sprintf documentation. So if you go into Matlab and you type doc sprintf, it will load up a documentation page all about sprintf and tell you all about how to use it. You may want to also look at doc fprintf to learn about file printing as well. So let's dive in here. If I take a look at this over here, we can see there's an sprintf fmt v1 v2 v3. So I'm going to call this sprintf down here a process. So you're learning about a new process in Matlab. This process takes 4 inputs. It's going to take a fmt as an input, that's a variable. It's going to take v1 as an input, v2 as an input, and v3 as an input. So it takes 4 inputs, and the output from this process is going to be a print to screen in a formatted manner. And we're going to see that as the example today. So fmt here as a variable is what we'll call a string variable. So you can see it's a string or a set of characters strung together, right? So we start off here with the A, right, which is area. It's in double quotes or in quotes. So we can see A colon, that represents area is going to equal to, that's us defining this output. %.3g, that's going to tell us that there's formatted output coming, right? SQM is the units for this particular output. That's square meters for the area. Then we put a comma, perimeter, colon. And then here we're going to tell Matlab there's going to be another print to screen of a variable, %.1f. And then at the end we have %s. So what Matlab's going to do is it's going to take these inputs of v1 and it's going to place v1 formatted right here where the % is written. So those percents indicate to Matlab's sprintf process that the v1 variable is going to be printed right here in the manner we specify. Talk about that in a second. v2 is going to be printed in the next location here, which is the %.1f format. And then the last thing we're going to print out is this meters unit, which is v3, and that's going to get printed here at the %s location. So let's just take a quick look at what these percent things mean a little bit more in depth, and then we'll go into an example. So %.3g means percent tells MATLAB there's an output going to be printed there, or a value printed there. It's going to have g, which is a number of significant figures of 3, as specified by me here, of 3. This one here tells us percent means that the next variable is going to print here. It has a value of 0.1f, right? So 0.1f tells me this is a floating point, and the 0.1 tells me there's going to be one value after the decimal point. If I put 0.2, there would be 2 values after that decimal point. Likewise, 3, there would be 3 values printed after the decimal point. So this is a way to print and constrain the values after the decimal point. The %s tells me that I'm going to be printing a string of characters, or a single character or a string of characters. So here, this value m is a character string that I'm going to print right here. By entering these inputs in this order, MATLAB is going to print to screen those variables in these % locations as part of the output. So this is probably best seen as an example. So let's go and jump into our example. Okay, so here's our example in MATLAB, and we're actually going to give this a try. So I'm going to start off by defining r equals 800. That is going to be an input for the processes I'm going to do. And then when we come down here, I'm going to say, this are my processes down here. So I'm going to do like this. I'm actually going to make this window a little bit smaller here so that you can see all that's going on. And then this is going to be my output command. So remember, our format for our simple programs are going to be there's inputs, in this case r equals 800. And then I'm also going to call this format an input, which is something I defined for MATLAB to use as the format. The processes I've got here are the equations for the area, the perimeter, and the units. And then the output command I've got takes these outputs from the processes and feeds them in as inputs to this new process. So what you can see is each of these blocks is its own little chunk of input, process, output. And we're going to start seeing that MATLAB programs, and lots of programs are built this way, of input, some process, then an output. Then we're going to use that output as an input to a new process, then output. So as we get more complicated, we're going to start seeing those things happen. So this is the exact same code that I wrote on the previous example on the screen. So let's just hit run and see what happens. So what we can see here is when we run this, right, we can see that the actual output is this str equals, and what we can see when it's printed to screen is we can see the a, or the string that's printed out is a 2.01 e to the positive 6, right? So we've got 3 significant figures here, right? Just like we asked. And then we said the units are going to be SQM, that's this portion here, right? So what MATLAB has done is it's taken the value of V1 and it's inserted it into this first output location of the formatted output. We can also get P, the perimeter, equals 5026.5, right? So that's the value of V2, most likely. Let's just copy and paste it down here and make sure. Take a look at V2. Yep, see, it's that value. And that's where it's printed down there. And then what we also see is that we printed this string value of M, which was V3, at the location of the %s. So these percent values have told us where to print things. So we're just going to change this up to being a %3, and we're going to make this one a %5. So you can see the change in significant figures and values after the decimal point. So let's hit run. So %5 has given us 1, 2, 3, 4, 5 significant figures now in this area calculation. And %3 here has given us 3 decimal point values in the floating point number. So what you can see is we can manipulate the way that the output looks so that it looks nice and clean for the format we're looking at. So just as a kind of quick run through, the way we told Matlab that there was output coming is we put a % and a format indicator. Here we put another % and a format indicator and another % and format indicator. We could compile all of that format into a nice looking format that we were going to print to screen. We could then insert the V1, V2, and V3 values into those % locations using the sprintf command. So what that sprintf command does is it takes those V1, V2, and V3 inputs, as well as the format as an input, and it plugs in, wherever there was a % sign, the appropriate variable ordering. And then as an output, you get this really nice formatted output, which allows us to format the output and print nice written things to screen. So if we wanted to make this even easier to read, we might do something like this. And then I'm going to do a \n for a new line. See if this works. Hit run. And what you can see now is I was able to put a new line in because I know that command for \n. Let's see if we can get it tightened up a little bit. And what you can see now is I was able to write area on one line and perimeter on another. I could also write it this way. Or let me actually write it this way, meters to the second. And what we should see now is we get the output of a different unit type. And then down here, we have already put a variable for that output. So hopefully this makes some sense. We can change the format. We can make it look nice. We can print things out to screen very nicely. So today, what we've been able to do is we've been able to do a few things. We've been able to create basic 2D plots, done some basic plotting, we formatted those plots, and we learned about the hold on command. So what I'm going to suggest for you on that particular thing is to practice some of the example questions that are posted down below in the description of this video. The other thing that you can see is formatting output to screen. So we learned about sprintf, and I also mentioned the fprintf command, which is very similar for formatting printed output to files. So these are all really great tools. And again, some examples that you can try are in the retrieval practice linked in the description of this video. So with that, I'm all done. Hopefully a shorter video this week. Next time we'll see you back for another brand new topic. We're going to get a little bit more complicated so that you can do some fun things in code and really dig in to knowing how to code MATLAB well. So until next time, practice, 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 retrieve, 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 and we'll see you then.